Continuing on that train of thought about multiplication of a vector by a scalar, a very important concept or parameter that gets used very often in dynamical system analysis and vector algebra in general is something called a unit vector. A unit vector. Some of you might know what a unit vector is. It's a vector of magnitude 1, or the pure number 1, I should say, a vector of magnitude of the pure number 1. Don't worry too much about what the pure number 1 means. This is just a very conventional definition. But if the magnitude is 1 of a vector, then it's called a unit vector. There is a way of taking any vector and finding its unit vector in a set direction. So the common way of doing that is the following. So given some arbitrary vector v, and you can see that I've used the tilde underneath the v to identify that as a vector. Its unit vector is given as the following: nv hat. So when you put a hat, a caret, over a letter in the alphabet, that typically refers to a unit vector, is defined as the following. This triangle symbol that I just wrote, let me rewrite it again so you see it clearly. So this equals sign with a triangle over it is the mathematical notation for by definition, right? So let's clarify that for a second. By definition. Right, so write that down. That's the mathematical symbol for by definition. So the unit vector n v hat, or the unit vector n hat along the v vector's direction, where v over here is a subscript, is given as the vector v divided by the magnitude of the vector v itself, right? So this second term, or the term in the denominator with the 2 bars on either side of v, is the magnitude of the vector v. nv hat is the unit vector parallel to the vector v, right? So these are all standard mathematical notations that you should be used to, like parallel is 2 lines that are basically parallel to each other. So given any vector w, right? Given any vector w, we can always rewrite this vector as some magnitude w plus n omega hat, right? So let's think about what this means graphically a little bit, right? What this means is that, say I'm given a vector w, right? There is a unit vector directed along this w, which is of length 1, which I can call n w hat, and if I multiply that unit vector with the scalar w, then I get the vector w itself, right? So both these are valid representations of the vector w itself. So unit vectors are actually very, very useful things. So just let's remind ourselves that in the above notation, nw hat is a unit vector parallel to w, right? And the scalar w is nothing but magnitude of the vector w. That is, let us rewrite this also in brackets to remind ourselves, that is magnitude of w. So that's basically this term over here is the magnitude of w, and that's equal to the scalar w. And when I say scalar, you can see that there is no tilde underneath a letter in the alphabet.